Good morning, guys. You're going to have to ignore noises in the background because I'm in the hospital. But I wanted to give you some information about ionic compounds. And I want to let you know that the reason that we name ionic compounds is because it used to be whoever discovered it named it based on their properties. So somebody discovered a gas and thought it made them kind of goofy, and they'd call it laughing gas. Well, there could have been multiple laughing gases. And as a chemist, we may want to make sure that we know exactly what substance it is that we're talking about when we're talking about laughing gas. So for binary compounds, which are any compounds that have just two elements, and that doesn't mean they only have two atoms, it means they have two elements. So for example, water, even though it contains three atoms, is a binary compound. Sodium chloride is also an example. So you need to remember from the ChemQuest that we talked about that there were two rules for writing ionic compounds. We always write the positively charged ion first, which, if you recall, is the name, the special name for that's a cation. We also always make sure that the overall charge on an ionic compound is neutral. So we have to make sure that the total positive charge of the cation equals the total negative charge of the anion. So if we look at our example of potassium and chlorine, potassium is in column 1A, therefore it has one valence electron. So remember, its choices would be to either gain 7 or lose 1. It's easier to lose 1, so it ends up with a positive 1 charge. We also have chlorine. Chlorine is in group 7A. It has 7 valence electrons. So its choices would be to lose 7 or gain 1. It's going to be easier to gain 1, so it gets a negative charge. So because we need to combine these so that our overall charge is 0, we have a total positive charge of +1, a total negative charge of -1, and so combining these in a 1-to-1 ratio results in a neutral compound. So we write our formula as KCl. If we look at our other example of calcium and bromine, calcium is in column group 2A, which means it has 2 valence electrons. So again, its choices to become like a noble gas, which remember is what everyone wants to be. They're the cool kids on the periodic table. Calcium could either lose those 2 valence electrons or gain 6. It's easier to lose 2, so calcium ends up with a charge of +2. Bromine, again, is also in group 7A, just like chlorine. Therefore, it has 7 valence electrons. It prefers, then, its choices would be to lose 7 or gain 1. It's going to gain 1. However, if I just combine these as 1 calcium and 1 bromine, my overall charge would be +1. So that doesn't work. So instead, I'm going to have 1 calcium and 2 bromine. By doing that, I end up with a 0 charge. When I write that formula, then, I write it as CaBr2. So that is those examples there. No matter whether you're writing the compound, or any time really you're writing the compound for an ionic compound, the rules are the same. You always write the positively charged ion first. Most times that will be a metal. The only time that might not be a metal is if you're dealing with the polyatomic ion you have memorized of ammonium. And number 2, the overall charge of an ionic compound has to be 0. It has to be neutral, which means your total positive charge of your cations has to equal the total negative charge of your anions. So you also remember that we talked about before that there was a shortcut for writing formulas for ionic compounds. And again, this will become something that you should be able to rattle off the top of your head. And that is, we always say it as symbols, charges, crisscross, lowest whole number ratio. So you'll see here that you're going to write the symbols for the elements, you're going to write the charges of the ions, you're going to crisscross only the charges, not the charges, only the number, okay? And then you always want to make sure that you have the lowest whole number ratio. So if we look at those same 2 examples again, looking at it with the crisscross, here I've done step number 1. I've written my symbols. Next, again, I write the charges. I figure out the charges exactly the same as we did the last time. Potassium has 1 valence electron. It's easier to lose that 1 valence electron, so it gets a positive charge. Chlorine has 7 valence electrons. It's easier for it to gain 1 electron, so it gets a negative charge. Now I'm going to, now I'm going to crisscross down these charges. So I'm going to take this one, it's going to go here. I'm going to take this one, and it's going to go here. So my formula becomes KCl. Not a big deal. Probably you won't crisscross down ones when you see them. However, when we take a look at calcium, which remember had a positive 2 charge because it has 2 valence electrons that it wants to lose, and bromine, that has a negative 1 charge because it has 7 valence electrons, so it prefers to gain 1. When I look at crisscrossing down these, I quickly see that my formula is CaBr2. So by crisscrossing, okay, so again, that's symbols, charges, and you can do those at the same time. You don't necessarily have to do one first and one second. Oftentimes I do write the symbol, write its charge, write the next symbol, write its next charge. Okay? Then you're going to crisscross. And then finally, you're always going to make sure you have the lowest whole number ratio. And again, let me show you an example of why you need to make sure you have your lowest whole number ratio. If you look at calcium, okay, so there's our symbol for calcium. Again, it has a charge of positive 2 because it has 2 valence electrons that it prefers to lose. And sulfur, which is in group 6A, so it has 6 valence electrons. So its choices would be to lose 6 or gain 2. It's going to choose to gain 2 electrons. So I have my symbols and my charges now. I'm ready to crisscross. I bring down a 2, I bring down a 2. Okay. However, notice here, I have Ca2S2. Is 2 to 2 the lowest whole number ratio? It's not. The lowest whole number ratio would be 1 to 1. So the correct way to write the formula for this compound is just CaS. That's why it's very important to check that you have the lowest whole number ratio. You will also see this sometimes happen. You may end up with a subscript of a 2 and a 4, so I'm just going to use like an X to say you have some sort of chemical symbols here. Again, because I have a 2 to 4, that's not the lowest whole number ratio. I'd write it X, X, 2. So it is important that you're always doing that last step. So those steps again are symbols, charges, crisscross, lowest whole number ratio. All right, now that you can write the formula for ionic compounds, what about naming them? To be honest, naming ionic compounds is pretty simple. You just have to combine the name of the cation and the anion. However, you're going to leave out the word ion from cation. So remember that we talked about naming positively charged ions, which are going to be your metals, when we're in a tall column, so the group A elements of the periodic table. It's simply the element name plus the word ion. For anions that are group A elements, so again, tall columns on the periodic table, we're going to take the element, and these will be nonmetals, okay? We're going to take the element name, we're going to lose its ending, and it's going to get the "ide." So again, we see that example here of potassium ion and chloride becoming potassium chloride as a compound. Calcium ion and bromide becoming calcium bromide. It's pretty simple to name monatomic single atom ions in general. Okay, when it's an anion, it's the element name minus its ending plus the word "ide." Where this gets a little bit more difficult, okay, and where it's not that it's difficult, it's that there are questions you need to ask yourself as you go through it, is when you're naming ionic compounds. You'll notice here I've noted that the first question you have to ask yourself is this compound ionic or molecular? Today they're just going to all be ionic, but the answer to that, you determine that answer For an ionic compound, you will look for something that is made of a metal and a nonmetal, or it has a polyatomic ion in it. For molecular compounds are made of two nonmetals. If it's an ionic compound, because again today we're focusing on ionic compounds, the next question you have to ask yourself is right here, which is the question of, is the metal in a tall column or a short column? So is it a group A element or a group B? Remember, the other name for group B is to call it a transition metal. Now, if it's in a tall column, it's simple because remember, in our tall columns, we only have one possible charge. We don't have to worry about having two different ways to name it because every person who's a chemist anywhere in the world knows that the only ion that sodium is going to form is sodium with a +1 charge. So we don't have to communicate to them which sodium ion we mean. There's only one. That becomes a little bit more problematic when we're talking about the elements that are in the short columns of the periodic table. Because when an element is in the short column on the periodic table, some of those transition metal elements have more than one possible charge, which means to communicate clearly with the people we're communicating with, other chemists, our classmates, your teacher in this case, you need to know whether that metal has more than one possible charge. So if it's a short column, then we just kind of go right back up here, okay, to the really simple, I'm going to combine the name of the cation and the anion. When we're in a short column, we kind of keep going this way. So if it's in the elements in a short column, the next question you ask yourself is, does the metal have more than one possible charge? You don't have to have that memorized. You're going to check your helper sheet that you received from me. If the metal is on the helper sheet and in the column with possible charges it only has one listed, then you still do just like these other elements where you combine the name of the cation and the anion. For example, silver and zinc only have one possible charge. Therefore, I don't have to use the stock system or the classical system to name them. However, if you look at copper or iron or quite a few of the other elements that are listed there, you'll see they have more than one possible charge. So when it has more than one possible charge on the helper sheet, we're still going to combine the name of the cation and the anion, but we have to somehow communicate which cation we mean. And to do that, okay, you're still going to go through this system of questions. So the next question that I hope you're asking yourself is, how do I know what charge it has? So we're going to work through an example here. We're going to look at this compound. Okay? So I've given you a formula and I'm asking you to name it. So remember that our first question was, is this compound ionic or molecular? Well, it's ionic because we have a metal and a nonmetal. Okay? Our next question was, is the metal in a tall column or a short column? So is copper here tall column or short? It's in a short column. So that brings us to our next question. For in the short column, our next question becomes, does the metal have more than one possible charge? You look at your helper sheet and copper does have more than one possible charge. So I need to name this, okay? But I somehow can't just call it copper oxide, right? Hopefully you're comfortable with this being oxide. This is oxygen, right? And so it's a negatively charged anion. And so we take the element name, it loses its ending, and it gets "ide." So it's oxide. The problem with this is chemists know there are multiple charges of copper, and so just calling it copper, it doesn't work. I have to tell which copper I mean. How do I figure that out? Remember those ChemQuests we did where we had something that was XO and they asked you to figure out the charge on this? We're going to do this exactly the same way. So to figure out the charge on a cation that I don't know, I need to look at the anion, the negatively charged ion, because I do know something about it. Oxygen's on my periodic table. It has 6 valence electrons. It could lose 6 or gain 2. It's going to gain 2, which means it has a charge of -2 charge. Also, remember that you know that one of the rules about ionic compounds is that overall they have to have a charge of 0. So right now I only have, notice, right, 1 oxygen ion, which means my total negative charge is -2. Over here, I have, sorry, it got loud. Okay. Over here, I have copper. Now, I only have 1 copper ion. So for this to be an overall charge of 0, this has to be +2. And I only have 1 of them, which means this copper has a +2 charge. So the proper way to name this, not copper oxide, the proper way to name this with the stock system, that's the one where you use the Roman numerals, is to call this copper 2 oxide. Okay, now I'm picky. I want to know that you know how to name it both with the stock and classical system. So you're also going to use the classical system. Now, to do the classical system, you have to look at your helper sheet, because I don't expect you to know what the Latin root of copper is. I do, but I've been doing this a long time. It's coop. Now, when I'm naming these, I have 2 choices of suffixes. It could be us or it could be ick. And I couldn't show you this the other day. Years ago, one of my students was having a hard time remembering this, and she remembers it this way. If I was going to build a pyramid with these 2 suffixes, I would put ick on top. So ick is the higher charged one, and us is the lower charged one. If that helps you remember it, that's great. So when I look at my copper on my helper sheet, it has 2 possible charges. It could be +1 or +2. This is copper with a +2 charge. So it needs the ick ending, so it is cupric, and it's still oxide. So I'm still combining the name of the cation and the anion. It's just in this circumstance, I have 2 options for how I'm going to name this cation. And so therefore I have 2 different names. Let's look at another example. Let's look at this compound. Again, going through our questions, I need those questions to become automatic for you every time you do this. So the first question is this ionic or molecular? This is ionic because, again, I have a metal and a nonmetal. Our next question is, because it's ionic, is tin in a tall column or a short column? If I remember the periodic table well, it's underneath. It looks like it's in a tall column, but it's underneath that heavy stair-step line, which means we call it a transition metal that we consider a short column. Okay, so we are in a short column, which means we trigger another question. All right, is tin on our helper sheet? It is. It has more than 1 possible charge, which means I'm going to have to name this twice. Again, same deal. How do I figure out its charge then? I look at oxygen. Again, oxygen never changes, you guys. It's going to have a -2 charge. I have 1 oxygen with a -2 charge. That means this tin has to have a +2 charge so that I get a 0 charge overall, +2. So the names for this are, stock system is typically easier to do first. This is tin 2 oxide. And the Latin root on your helper sheet for tin is stan. This is the lower of the 2 charges because there's a +2 and a +4 on your helper sheet, so this is StanUs oxide. Contrast that with this compound. Again, same 2 elements, right? A binary ionic compound. We still know that oxygen, right? We go through all of our questions again. It's ionic because we have a metal and a nonmetal. Tin's in a short column. It's on my helper sheet, so I need to figure out its charge. Oxygen still has a -2 charge, but now I have 2 of them, which means my total negative charge is -4. I only have 1 tin. My total positive charge has to be 4 so that I get an overall charge of 0. That means this is tin with a +4 charge. This isn't tin 2 oxide. This is tin 4 oxide. Okay? The other way to name this, again, that I expect you to always do, is still stan, but this is the higher of the two charges, so this is stannic oxide. So there are our two possible charges for these compounds. I hope that helps.